remind us. Highly appreciated. Good job. Yeah, I will make now the recording. What about if I want not to make a projection? I want to get the values, the whole values in the table. In this case, I can use a star. Select a star. So in this case, I'm not making projection anymore. I'm getting you the whole data from this table. Do you remember when we talked about extended projection? Anyone remember this? I think so. We talked about this in the last lecture. Anyone remember this? Not the classical projection, extended projection. Okay. So extended projection says that we can apply a mathematical operation to the attribute that we are going to select or project, sorry, during the projection process. This is the same, we can do it here also in the select from statement. So I can ask to get ID and name, and also the final result, I doesn't need the salary. I need to divide it, the whole values by 12. So based on this query, I will get this ID. The whole ID, we have it in the database, in the table instructor. And then I have the name, the corresponding name. And I will not get the corresponding salary. I will get salary divided by 2. So for each record, it would be divided by 12. So I can apply, and this is an extended operation that I can use it, projection, with the select from statement. Rainy is here. Let's see what you want to ask. Select the correct answer. So anyone know the answer, raise his or her hand, and I can start getting your. So that is the keyword eliminate duplicate rows from the result of a select statement. So Asira, go ahead.
Distinct?
Yes. Distinct. Yeah. We have many people say distinct. Let's see what the brain is saying. Yeah. Distinct. Thank you so much, Harmandeep, Wilson, and Simran and Josh. I see also in the chat. Oh, there are Zach. Oh, I'm happy. I see many people participating here. Yes, distinct. So we can use distinct as a part of the select, as we said, to make a duplication elimination. Let's see now Cartesian product, how we can write the Cartesian product that we have already known about it, how we can apply this here now, or how we can write the SQL code. So if I want to make a Cartesian, that we know about what is a Cartesian from the relational algebra, I can make select a star. However, rather than writing only the name of one table, I will write the name of the two tables. This is the same like this, that we know it in relational algebra. So we can use select from to make a Cartesian product. And as far as you know, the Cartesian product is you get the row from the first with the whole row joining with the whole row in the second to get a huge table that has this combination of rows from the first and the second. So select a star. From we name the name of the two tables in this case that we are joining them. Natural join. Natural join, I'm just, since you are familiar what is an operation, so just I don't have to re-discuss what this operation do, even though we are discussing very quickly, because we know this from the relational algebra. What we are doing, we are making mapping between the relational algebra operation and how we can write in an SQL. Because later, when we'll practice this in the database management system, we have to write SQL query, DML query, and this is what we are learning today. So the natural join, there are two options to do this. Either select from where using the same select from where clause, or we can make select from rather than using where, because if we go to the first one, based on the definition of what is a natural join, we are going first, we should have a common attribute. No common attribute, no natural join. And if you make a natural join without a common attribute, then we will get an error from the compiler of the SQL. Because we said a natural join, I'm not talking about inner join or join, the normal join, I'm talking about natural join. So far, based on the definition, there should be a common attribute. And the joining will be based by getting or joining the rows that they have common value in the common attribute or equal value in the common attribute. So if I can use select from where to do the joining based on this condition by saying, I'm selecting, forget now about this. This is, we have a projection here. Let's suppose I'm making a star from instructor teach as I did with the Cartesian. However, I said where the values in the common attributes from both cases are equal. Or I can use the keyword natural join that we have it, even though in MySQL we have this. When I'm saying MySQL, even though SQL as a language, it is not directly related to a database management system. It is a standalone language. However, there are different versions for this based on database management system. There will be extremely slightly different from database management system to the another when we talk about SQL. So what we are discussing here is the SQL version for MySQL database management system. It will be almost the same if you go to any another database management system like Microsoft SQL or whatever database management system or Oracle you are going to deal with it. However, there will be a slightly difference, 2 to 3%, 5%, where we will have a special syntax to this database management system. But overall, they are almost the same. So here we will have a keyword named natural join. Rather than saying from and make a condition, we can just use it. In this case, we don't need to write the where condition saying that the values from the common attribute should be equal. If I will write this in relational algebra for both, which are the same, I will write instructor natural join with teachers. And since I'm making a projection here, I'm selecting a special attribute with the joining. So in this case, I'm making also projection, name, and course ID. So this is in relational algebra how it will be and how I can write in SQL using the first one or the second one. Both are correct. We have two options in this case. Any questions so far? Okay, Brain will ask you now, and you should know. So this is if I don't want to make a projection, just select natural join. So I will say select a star from instructor natural join teach or from instructor teachers where instructor.id equal teach.id if the ID will be the common attribute here. And we will get an output, which is a table that based on the joining process that will take place. Brain is asking. So select the correct answer. Which users are developer? So the question is, you have this database, and you want to create a query. And this is what will happen in database management system later on any database software, that you will create different report, and each report will be based on a query, or you have going to make any displaying for the values based on a query. So the question is, if I want to get the users, not the whole users, just the users that they are also developer at the same time. So which query is correct? The first, the second, the third, or the fourth in this case? I will give you 1 minute to think about it. It should be a very easy one. Okay, let's see in the chat. Maybe there's something in the chat here. Go on the chat. I have C or D, C, D, C, C, and C or D. Okay. I will, Josh, can I discuss with you the word C or D is?
Yeah, sure.
Okay.
So I selected C or D.
First, okay, let's see, because there are some people here saying C, 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 C. So let's see what Brainy has an answer. Brainy says it's C. And since he's Brainy, he's always correct. So, so let's discuss why you said C or D, not only C.
So I said C or D. The only issue is that D might not be unique because the full name and the developer name might not be unique.
Yeah.
But it'll still give you the right answer to some extent, I would say. But
yeah, you said to
C
some extent,
is the more correct answer.
Yeah, yeah, this is the point. So it is not an accurate one. Because as you said, so if we are going to make a matching between the names only, between the two tables, maybe I will have the application with the names, and now I will not get the good matching. They are not unique. So using the email, it will be better in this case. Okay, why it is not B?
B, because we don't have any matching attributes between the two. So it wouldn't know which one to actually naturally join.
Yeah, that's good. Let's now discuss more about this. So in the table users and developer, we have the user email and developer email. Some people said, okay, well, they are both our emails, and we can use them to make this natural join by getting the equal in this two. In this case, we got users and we got users and that are developers, because this is an email, this is an email. If you make this natural join, then in this case, we get it. But you will get error here, because the name of the attributes are not the same. So if you are going to use natural join, you should use renaming to get the developer a copy from this, rename the developer email by naming it user email, and then you make a joining. So even though you know that the data that we are talking about similar data, but if in the structure in the database, the name of the attribute are not the same, so you will get an error for joining. Josh, why not A?
Well, that one doesn't even do natural join. It's just a Cartesian product, is it not?
And since we are searching for not the whole users, we are searching for just the users that are developer. In this case, this will make join for the whole data with each other. We get the whole data in this case, and then this is not what we are searching for. Is it correct?
Yep.
Thank you so much, Josh. And I want to thank all people here in the chat: Cora, Ayman, Sarsak, Nassan, and Kelum. Yes, thank you for this email. And Now, Vipun also give us an answer, even though it was not correct, but thank you so much for participating here, and Alan also. So let's continue here in this case. So now we were discussing about the renaming operation, and we know rename operation from a relational algebra. And as I told you, the renaming doesn't change anything in the structure. So when we are dealing with select as a select, we are not changing anything in the structure. We are just getting copy and making the joining or other operation. So I can rename the name of the output attribute. So before this, we had this example where we said, okay, we can make a salary divide by 12. And if I didn't make use as, then I will get the output will be look like this: ID, name, and salary divided by 12. But if I want to give a name for this, I can use as. I name it monthly salary. So I can use as to change the output of the name of any attribute, or to change even though the name of the output table, not just the attribute in this case. Operations. So when we were, I'm not sure if in this class or in the other section, because I'm teaching 2 sections. I remember once a student has asked me that if we are going to make this condition always was about greater, less, or equal. So what is so how if we are dealing with an attribute which is not a numerical value? An attribute that it is not a numerical value, an attribute where it is like string value. How we can say, for example, you have the first name in the table, this table, and you have the first name in the other table. How, or you have name, whatever it is a name, and you want to compare 2 names of each other. We can't use greater or less in this case. Maybe we can use equal if we need exact name, but if we are making just comparison, how we can build a condition in this? I said, yes, that's correct. So SQL later, we will give you an option to use something, we name it template or pattern. In the pattern, you are able to create your own pattern and make a comparison based on this. And this is what we are going to discuss now about how we can, whenever we have a condition based on string operation, how we can do this. There are so much detail. I just picked the most important from them to discuss it here, that it will help you to create an SQL query where you will build a string comparison in this case. So string operation here, we will have in the where, we will lose like, not equal. We will not say name equal, we say name like. If you see there is something here, percentage, they are percentage. So in this case, mean that this is not the exact string, this is the pattern I'm searching for. If I use, as we mentioned here, if I use percentage like this, mean that I'm searching for a name that contains DAR. I don't care about what will come after R, and I don't care what will come after before D. So percentage mean I don't care about the rest of the strings or the character that come after this character or before. If I will not use this one, I will use it like this. It means that I'm searching for the name that starts with DAR. I don't care what comes after DAR, but it is a must to start with DAR. If I write it like this, mean that I need a name that finish with DAR. I don't care about what will come before it, but it should be at the end AR. So in this, I'm building a pattern that I'm searching for using the percentage as a part from the string. If I go into like, this is what we were discussing, but what about the underscore? Underscore means that I'm not searching for exact character, but I'm searching for exact number of character. So if I use this, mean that I'm searching for a name that is 3 characters only. If I use a percentage with underscore, here, for example, this, it should be at least 3 characters. Because I use a percentage after, so it should start with a 3 character. I don't care how many characters later will come. So underscore give me what is the number of characters that I'm searching for. Here, there's mentioned here that what about if I'm, and it is very, very rare cases, but it can be, if I'm searching for this text, so it is not anymore, I don't want to consider it as a pattern. I'm searching for 100%. I'm searching for this text. This is here, the percentage doesn't work like a pattern anymore. So I can use this. Having this escape mean that in this case, I'm telling the compiler, please escape this. It's not apart from a pattern, it's just a character that I'm searching for. Any question about this? Okay, Perini will ask later. Order by. This is what we named sorting in relational algebra, if you remember this. Here we can use order by. And either we'll make sorting, as we discussed before, using the name of the attribute, or we can use more than one attribute. In this case, we will make sorting based on the first. And if we have a tie, which is we have equal values, then we can consider the value of the second. It will be by default ascending. But if we want to make it descending, then we have to write descending after the name of the attribute. Again, it is, you should consider the structure. As I said, SQL, it is not a case sensitive, but it is a structure sensitive. In this case, if you can't write order by before from, and if you have a where, you should write where, then you write order by. So order by will be the last one to write it. And so select from, if there is a where, then you have to write where, and then you said order by, or the vice versa in this case. Any questions so far? Okay. Yeah, he will ask you. So select the correct answer to display the detail of employee having E in their name in the descending order of a salary, the correct SQL in the descending. We want to search for a detail of employee, the whole data of an employee that have E in their name, and visualize the data by descending order of based on the salary attribute. So which one is correct? Only one of them is correct. Okay, I got some answers, I think so. I got most of the answers say B. Let me check C. We have Josh saying D. And we have some people saying C, some people saying D. And we have majority say D. Okay, let's see what will be the answer. So the answer will be D. Let's discuss it. Who want to discuss it with me? I want somebody rather than Josh. Josh has already discussed one. So from the people who replied D, I need to discuss it with one of them. Is there a volunteer or I have to choose one? Okay, I will choose one. So don't worry, I choose Zach. Zach, do you have a mic?
Yep.
How are you today?
I'm all right. How are you?
Good. Sometimes I'll be happy to hear your voice because we don't meet in person. This will give good indication that you are doing well. Okay, Zach. So let's go one by one. Are you ready?
Yeah.
So the first one, why it is incorrect?
Right off the bat, I saw that the E wasn't like encapsulated by the percentage.
Yeah, that's correct. So we are searching for the data for employee who has E in their name. If you will use this, mean it is just for the employee that their name start with E. This is not the case because we don't need only the employee that their name start with E. We need the employee that they have E within their name. It can be at the beginning, at the end, or in the middle, or any place. So using this as a pattern, it is incorrect because this is make a limitation for only employee that their name start with E. Do you agree on this?
Yeah.
Okay, perfect. Let's go to the second one, to the B. Why B is not correct?
Right away, doesn't where have to be like way before order by?
Yeah, this is what we have already mentioned many times today in the lecture, that we should be aware about the sequence of the instruction. So order by should not be before where, it should be after in this case. So this is incorrect, this is incorrect. What about the C in this case?
It's right at the end. You have to put descending after the attribute.
I'm happy to have you in our class. You are extremely smart. Yeah. So that's correct. We should have the descent after the name of the attribute, not before, or we get an error. So it is like when we write any code like Java, or Python, or whatever code, so we should be aware about the syntax. So here, we shouldn't write the descent before the name of the attribute, should be after. So in this case, D, it will be the only correct solution. Thank you so much, Zach.
Yep.
So now let's go to the set operation. Set operation. What we name it set operation, it is union, intersection, and difference, what in the relational algebra. Here we have union, union plus, intersect, and minus. And also except is already being used, but minus is widely more used for difference. There is it is just in the set operation, not like other operation. All other operation, like in joining and selection and projection and all other operation, always SQL will deal with the tables as a back. So the application will be allowed if you don't use this thing. Here, there is a differentiation between union and union plus. So union means that the output will have no duplication. Union plus, the output will have a duplication. And I mentioned the example not for a one table. No, I just as if, and I didn't say for table A and table B, because to be realistic, there is a condition for, if you remember this union, intersection, and difference in the relational algebra, that we cannot apply those if we don't have the same schema. So the two tables should have the same schema, should have the same list of attribute, types of attribute, all this stuff. And normally we will not have in the same database two tables have the same schema. The case will be that we got values based on a special schema, and we got another values based on the from another table, and the output from both queries will have the same schema, like here. So I create the next lecture will be about nested query, how we can have more than one query in the same query. This is a simple case about it. So I select city from students. So this is the first output. Sorry, I will select city. So I will get from this table from student, and this is student too. So it is a copy. So I will get this is from the first, and I will get this is from the second. And then I want to make union, which is here. I use union. Union say that I have to get the common. I get the whole attribute from both cases. I'm not making a joining, collecting as we did before, collecting the attributes from the first and the second with each other. And since I'm using union, not union all, so no duplication is allowed. So here I have Texas, California, Alaska, Los Angeles, New York. I will take this here. Texas, I already have it, so I will not take it again. Los Angeles, I have already, I will not take it again. California, I have it, so I will not take it again. New York, I have it, so the rest will be this output: Alaska, California, Los Angeles, New York, Texas. This is the union from both in this case. If I use union plus, union all, sorry. So now, again, I'm taking this, the same like before, and I'm making union. So the output will be like this now. There is duplication already. So Alaska, I have it once here, and the other, like Texas, I have it in both, so I have Texas too. I have New York on both, so I have New York too. I have Los Angeles here 2 times, and I have here Los Angeles 1 time, so it will be have 3 times here in this case. So union plus, the only difference that duplication. This is only for union. We have intersect. Intersect also retain distinct, doesn't make a duplication. Then so the same like union, but intersect we get the common. And the difference that we have it at a difference before, we name it here minus. And as that there is also except. It can be used in MySQL, but minus it's more widely used. This is why I mentioned here. So this is a set operation that we know before, how we can write it here in SQL in this case. Aggregation function. Aggregation function. You want to take a break or we can continue? So people that need a break, now it's your opportunity. If I get 5 thumbs up, I will go to the break. No thumbs up, I will continue. How many thumbs up I got? I can see it. I got, it seems that I got more than 5. I still have coffee left. Okay, Ivan. So it seems that somebody need, I will not give you a very long one, so let's make it short. I will give you 6 minutes. So we 9:29 now, we will be back 9:35. So just make a refresh, get your coffee if you need it. So 9:35, we'll be back here to continue what we are discussing today. See you very soon. Okay. So we return back. We should, most of us, be back here now. So aggregation function, aggregate functions that we also discussed this before in relation. As you see that I'm using also many times the word we have already discussed, as we discussed, as far as we know. And this was the main aim from the relational algebra. That to be familiar with the operation before we understand more the syntax. So it will be a very easy job now, just understanding the syntax. We are more familiar about the operation, how it works from mathematical perspective. From mathematics, we know about what it will do. Just now, what we are doing is what will be the SQL code to do this. Because our database management system understands only SQL code. So the function that we said as aggregate function is average, minimum, maximum, sum, and count. And in the relational algebra, we have count and distinct count. Here we just have a count because we have the distinct. So rather than saying distinct count, we can say count, and then we write distinct for the name of the attribute. It will be the same like distinct count in relational algebra in this case. So, and we can use it here, like select average salary, and apart from the select from where. In this case, I will get only one value, which is the average salary for the whole tuple in this that satisfies this condition. Here I use count distinct, so I will not consider duplication in this case. And here I said select count star. So from course, in this case, I will get the whole number of tuples in this table. So either I can make an aggregate function with a condition by selecting special tuples to apply this, or I can make count distinct to ignore duplication, or I just can use make counting for the whole list of tuples I have it, or rows or records I have it in this table. When we were discussing relational algebra, we said aggregate function normally will be always with relational algebra. Will be always with a group by, and most of the time. And whenever we use it with a group by, then it will be applied for per group or per category, not the whole data. So we have a group by. So like here, I'm saying select department name and average salary, a group by department name. This is if I want to write in a relational algebra, I write it like this. Group by department name. And if I said average salary, okay, from which table instructor. So this is as a relational algebra, this is as SQL. And here the average salary will not for the whole data. It will be applied per group based on the department name. So this is the main table. This is we have already discussed before in relational algebra. So we have this is a main table, and then I make a grouping. And then I will apply the aggregate function per group. So I will get for the biology, I will get for computer science, I will get, so biology, it will be, since I have only one, so it will be the average salary. So here, computer science, I will get. So I will get, so you as a computer scientist, you have the highest salary, it seems. So just Einstein is better than you. So keep it up, you as a computer science. So we have it here, the value of the computer science. You see, Mozart, yeah, is only making 40K. People doesn't respect art. They just respect science, not because they like science. Because to make money at business, they need science to create their own models and make own prediction model and stochastic model to make the prediction for this business. So yes, Mozart is only 40,000, and this is unfair. So we will have here an average, which is summation of these three values divided by 3, we will get this value. So we are applying, in this case, the average per category, as we discussed today. So now, what if I want to create a condition? What to create a condition? Yeah, just like sometimes I talk about, this is the value is not incorrect, but the person, this is a table that has been created from textbook. That, especially in the world of the business, there is a big question about the ethics. That now, this is out of the course, but I always ask myself my question that whenever we have more technology, we have more advanced technology, is it used in the correct way for humanity? Or people who pay for us to make research and funding all this, they expect a special orientation for this research and this technology. And they use it, like here, all people on the start was talking more popular AI and machine learning, and this was bombing. We will be happy that we are as a human being, we are clever and smart enough that to make, to use or to build a model similar to us. That's similar, it's not similar, but it can be somehow close to the way we think that creating this, what you name it, machine learning, all this stuff. And then you start seeing that people, the business owner, they are, and the elite, I name it the elite environment and community, they start using this to collect data of the whole people, to understand more the behavior of the people, to see how they are going to sell them product without having any privacy consideration, without considering anything about this. For now, for them, we are just numbers. And they are tracking what we do to see how more business they can do it or enforce us to do it. I use the word enforce because even though sometimes many people, they will get many advertisement in a very catchy way because they know that this person or somehow will be interested in this. But if you present in a very catchy way, then this person will not have the correct balance to say no. And sometimes you are telling people what they don't need because you know, based on analyzing their data, that will be interesting emotionally for them. And in this case, I name it enforcing about this. So yeah. So when we talk about art, I think so there is a bigger subject which is about ethics. So returning back here about group by and having. So what about if you want to make a condition based on the output of the grouping? So after I make the average per department, I don't want the whole department to be listed, just the department that they have an average salary greater than this amount. Here I can't use the normal where, because where will come before group by. Select from where, then group by will come. So the where condition will be applied before grouping. So if I want to apply a condition after grouping, then I have to use another keyword or another instruction, which is having. So as Papa said, having clause condition are applied after the formation of the groups, while where clause conditions are applied before forming groups in this case. This is very important to understand this. But why you need to have a having and not mix between having and where? Hey, Brainy is here. So Brainy is asking which query output the developer ID and the number of apps that was developed. So maybe it is somehow need to more clarify it here or rephrase it. So we need to know the developer ID and the apps that they created. And the apps that they created that was developed. So what was developed by these developers. So we need to get the developer ID and the number of apps that each one of the developer has already created this. So is it C, D, A, or B? I'm getting so much C, but not always the majority is correct. Oh, I have so much C. Okay, I will give 30 seconds more before I'll ask Brainy for the question, for the answer, sorry. Hey, yes, C. Kura, I want to hear your nice voice today. Can you discuss it with us why it is C? Kura, are you able to speak using your mic?
Hi. So it's C because we need to count the app. So
Okay,
we count it by the Apple ID.
yeah, let's if you accept, we can go one by one to say why no.
Okay.
So let's
Okay.
start with A. Why A is incorrect?
Because it is just we select from it is just sorted by developer ID, not counting the number of apps of specific developer.
So what is the mistake here? Are you aware about the mistake here? Why it is incorrect here? So I'm saying, okay, select developer ID app. So
Yeah,
first
there
is no counting.
Yeah, no
and
count.
We need a number.
Yep,
And there's something named sort by, even though we
by.
use order by. So there is more than one
Yeah.
mistake here. Okay, let's go to B now.
So B, no count for the apps. So
Yes.
this is not correct. And
Let's go to D now.
So for D, it's count the developer ID. It should be the apps, not the developer ID.
Perfect. Always said moms that they have some kids, they will be very smart. I don't know why. Because they know how to deal with the kids, and kids are very smart, so they will be extremely smart in this case. They will have more high capabilities than others. How is your kids?
Oh, they're good. Yeah.
Happy I'm here. They're good. Keep it up. Take care for them, and they will take care for you also.
Thank you.
Okay, thank you so much, Kura. I'm really appreciate your interaction here today. Yes, so the last one, which is a D, in this case, we are not counting the app, which is we are counting the developer. So C will be the correct one because we are counting the app ID. So we are applying aggregate, and there is a group by developer ID. So in this case, the counting for the app, it will be per developer in this case. Yes. So outer join. For today, we will talk about outer join. What is outer join? Outer join, we discussed this. Here I'm mentioning it as a natural outer join, even though outer join can be as a join or it can be a natural join. Natural outer join or can be an outer join, which means when I said natural outer join, then it's be based on it would be based on if to apply it if we have a natural join, which means in this case we have a common attribute, and the joining will be based on the values in the common attribute if they are equal. But the added comparing to the to the classical natural join is that if we are discussing, as we did in the relational algebra, if we said left outer join first, let's make the natural join, the normal natural join, just to remember how it works before we go to the statement. So the common attribute here, we have a course ID and we have a course ID. So here we have a common value. So we will make a joining. I'm talking about natural join now. Here we have a common value, so we are going to make a joining. This value doesn't exist here, so this is we will not. So the output of natural join will be till here. If I use not natural join, I said left outer, natural left outer join. In this case, I'm not allowed to lose any record from the left. So the left one that I missed, I will add it again with the whole values, but it will not be connected to any value from the other part, so it will be null. So here we use the word natural left outer join. This is already exists in my SQL language. The same we have here, natural right outer join. So in this case, I am not allowed to lose any value from here. The whole value should be here, and if that doesn't have like here, it doesn't exist here, so it will be with a null value from the other side in this case. Full outer join. So I will not allow to lose any value. So this will be mentioned with a null, and this will be mentioned with a null in this case. So there exists already a keyword that can be used as an operation, which is natural outer join, either full, right, left, and the same outer join that we discussed in the relational algebra. So this is what for today. Even though there are more, but I don't think that I should give more data in one lecture. So it's better now to practice the lab exercise, very easy one. And the next lecture, we will go more advanced in the examples. And that's the next lecture, we will finish the course content. We'll talk about SQL. Now, in this case, you know how to design a database. You know how to make a normalization, and you know the whole process of designing. You know how to create the tables. And now you know, with plus the next lecture, you will know how to select different data and different conditions. And the next lecture, we will learn how to insert and delete and update. And we will have more practice in the next lecture. So the next lecture will be the final about the code. And as I said, I think so. Before we go to the lab exercise, let's double check the calendar. I'm okay, even though we have so much Monday that because we have so day, but I build the course content based on this. So all good. So I think so we have 2 more lectures, the 28th and the 5th. Yeah, cool. I will answer your question. Yeah, so 28 and 5th, so 28 will be the next one that we will finish. 5th will be for group project. I will make demo either in 28 or in the 5th, how you connect a software with this one. So if we still have time and you still have energy next time, I can make the demo, which is, as I said, it is an optional. It is not required, but will be very nice to do it. Or I do it in the 5th before we start presentation. I will see based on the progress of the lecture. But the next lecture, we will finish the whole course material. And December 5th, which is the last one, will be for project presentation. So we will use exam next lecture. Yes, we will use exam next lecture. Because next lecture, we will apply in the lab exercise. I will ask you, after we finish the more how to create a nested query and make insert, select, and update, then I prepared already a lab exercise where I will ask you to create the tables and then start inserting values and then selecting all this stuff. So yes, we will use the exam next time. Kura, question about the project presentation. Go ahead, Kura. What do you have a question before we start our lab exercise?
Do we need to record the presentation and send it to you, or we actually
No, this is,
present?
we should actually present. This is, we did it when we have an OLO course, which is asynchronous. However, our course is OLM, which is synchronous. Students expect to attend live sessions. So in this case, they are expect to make a live presentation.
Okay, that's all. Thank you.
Thank you, sure. So the lab exercise for today, anyone have any question before, or still we can ask me after the lab exercise. So it's very easy one. It's very simple queries. I don't want to make it complicated for this. More complication will come next lecture. And I'm happy that we are able to finish on time the course material. So consider the following database schema. We have Movistar. I think so we are familiar with this, but I didn't mention the key, so we are okay. So this is, please, if you can take a screenshot because you don't have this in your, go ahead and take the screenshot for this. So consider the following database. You need to find the address of MGM Stadium from. I will not discuss it. I will keep discussion during the, like always, a group work exercise, and I will join you in different rooms. So please take a screenshot now. All of you take a screenshot about this. I will break down you to different rooms, like always, and you will discuss with your colleagues about the different queries that we should write it here. Thank you so much, Navipon, to share it. And then we return back to the main room, like always, to discuss the result in this case. I will stop sharing. I will make a room, I will break you down to different rooms now. I should delete the old rooms. I don't like to use the same rooms. It's really good opportunity that always you will have a new colleagues, and then you will have a more discussion, a more interaction. So create rooms. Okay. We start creating the rooms now. I will open the whole rooms. You should now go to your room. Why Harjut is not assigned?
it.
Okay, guys. Still there we are all here, or still there are some people that the room doesn't close. All are closed. Okay. Any group? I double check with some of you during. So, any group need to share their solution with us today? Josh, we are happy that you are be here always. Very active. I'm extremely happy that you are here. Go ahead, Josh. I think
All
so,
right,
Josh, just I remember something. Josh and Ivan, you
Yeah.
once asked me about Sench 430. Because it seems that I received many emails, almost 4 emails from students. They are taking a graphic design course, and they told me that there is 10-minute conflict, and then I give them what we name a time conflict waiver. So I said, okay, you can come late 10 minutes, it will be okay, because normally it will take us 5 to 10 minutes till we start our lecture. So if you have this case and you need to register this course, it seems that there is an option where I can give you a waiver, so the system will allow you to register. Just I remember this.
Oh,
Yeah, I don't have any time conflicts myself. I've already gotten that waiver before for other courses, but yeah, no, I'm okay for this semester.
Okay, that's good. So anyone want to suggest yourself? I was not aware about this waiver. I knew about after this case. So any student want to register this course and still need a waiver, just drop me an email. Okay,
yes,
go ahead,
I will
Josh.
do. Because I
Hi,
think I
Ivan. Yeah,
definitely
sure.
have conflicts still.
Yeah, go ahead and register there. Maybe you'll be in the waited listed, or maybe, and then I will give you the waiver, or maybe I need to give you the waiver so just to try it and see what do you want from my side, and we'll help you in this.
Sounds good.
All right, can you see my screen?
Yes, we can see it.
Okay, awesome. So for part A, we were asked to find the address of MGM Studios. So we started with the select statement to select the address, and then we wanted to say which relation from. So we said from studio, because that's where we'd get our studio. And then where the name has to equal MGM Studios. So we'd get the address of MGM Studios. For part B, very similar to part A, it's pretty much the exact same format where we're asked to find Sandra Bullock's birthday. So we select birth date here from Movie Star. And then where the name is Sandra Bullock. So you're just getting the birth date that way. Next, we were asked to find all the stars that appeared in either a movie made in 1980 or a movie with love in the title. So in this case, we're doing the same thing as before, but now we have 2 conditions. So we're going to have an or statement because we're asking for or.
So in this case, we can build, this is good practice, that in where we can include more than one condition by using or and if you want to have the 2 conditions at the same time or one of them. Go ahead, Josh.
So we're doing a select on star name because we're trying to find the stars that appeared. So we're doing star name from stars in, since we're trying to get the year as well as a movie title. We're trying to check against those. So we want to do stars in, where the movie year equals 1980 or the movie title has love in the title somewhere. It doesn't have to be at the start or the end. It's just anywhere in the title. So we're using like to do that. And then we have a percentage sign behind before and after. And this tells us that we can have anything before and after.
Yeah, because we are searching
next.
for that love to be in the name. So it can come with other word or at the beginning or the end. So yes, so we have to use percentage before and after the word in this case.
Next, for part D, we were asked to find all executives worth at least $10 million. This one's the exact same as part A and part B. You're just selecting. So the only thing that you're trying to find is which relation is this referring to. So we're looking for executives. So we go to movie exec and we select the name from movie exec. And then the condition is that they're worth at least $10 million. So we just said net worth is greater than $10 million. And honestly, we could probably make that greater or equal because that it's at least, so it could be greater or equal. So yeah. Next for part E, we're asked to find all the stars who either are male or live in Malibu, have string Malibu as a part of their address. So what this is telling you is it's giving you a hint that Malibu is going to be part of the address. And all we're trying to find is stars. So we want to look into the movie star relation. So we do select name from the movie star relation, where address is like Malibu. So we don't know where Malibu is specifically in this address. So we're going to put a percentage sign on both sides just because it's not really stated. So we don't know. So that way it can be anywhere in the address. If it says Malibu, we'll count that. Then we have an or statement that tells us, hey, it's either they live in Malibu or are they male? So if they're male, we just check for the gender equals male. And that's how we get the relationship there.
Amazing. Do you know that I will give you a feedback about your presentation skill and instruction skill? You will be a good instructor. I know it is not an
I don't
easy
want to
job.
instruct, I'm sorry.
I will tell you something about myself, even though it's out of the box. So I never thought that I would be an instructor. Because when I was in the university with my colleagues, even in the school, I don't have so much patience to discuss material with the other. Because I remember at that time, I understand it somehow in a quick way, but I don't have enough patience to discuss so much detail with the others. I never thought I would do it, so don't say I will not be, or you don't know what will happen later.
Well,
So-
it's not a patience thing. It's more of
So,
a,
and
I'm
later,
a greedy
after
bastard and I want money.
Yeah, so I finished my master and I start working with the industry. And there was my master thesis supervisor and told me that there is an opportunity, you got a scholarship. It was a European scholarship because I was in Germany at that time. So he told me there is a European program and he was in the committee of this. I said, I highly recommend that you apply there. I said, but I'm working, I'm not because I'm planning to have a PhD. He said, no, you should do it and you have a nice outcome in your master thesis. So I don't know why he asked me to do this, and then I go it, and then I get a PhD. When you finish a PhD, then you will be an university professor, so you'll be an instructor. So don't know what will happen later. Maybe you'll be a colleague and you have a PhD, and then I will see you at UFV teaching courses with us. Don't know. Don't say no.
Maybe. I'm a greedy bastard and I want money and
Yeah, all we know is all we want is don't worry about it. But I said sometimes
so
you don't know what will happen. Thank you so much, Josh, for you and all for today. And I really appreciate your participation. Sometimes if we have other students do this, do I prefer teaching or working? Is it for me, Callum, or for Josh, this question? Is it for me? Yeah, then it's for me. So when I was working as an engineer, I worked for this and still I work as a data scientist consultant. So I still work in the industry. I think so being in the university, it gave me a good opportunity because working in the university, not only teaching, it's apart from this research and updating yourself. And sometimes giving courses, it pushed me to update myself, to read more. I like it because it doesn't need so much effort. And it gives me better social life by sitting at the computer the whole day. Because when you be, especially now after most of the people working remotely, so if you will work as industry, you don't have so much, as a technical post, you will not have so much social interaction. The best scenario if you can do both. It is not an easy, it needs time management. So I think so after being a university professor, I like it more comparing only being as a programmer as I was before. And now I'm working with industry as a data scientist consultant and teaching. So yeah, thank you so much, Colin, for your question. Josh, go ahead.
I was curious if you'd be willing to talk more about that, because I think that would be interesting to do, is doing both.
Yeah, but it's not easy from the beginning. You have to choose one of the track, and then the other one can be minor in this case. And the more senior you will be, the more time management you can do it, and then yeah, then you can do it in both. But again, so university working environment, and I think so even also maybe talk about instructor. So it's not the same being instructor in a school, because as a university professor or university lecturer, whatever it is, still you have a room to work in the industry in parallel in your domain. So in this case, you can do both, but you can do it from the beginning. So you have to start either, if you go teaching, you have to give you some time to have a solid background in teaching, and then you can go again to the industry to work in parallel. So the problem was time management. And it is not an easy job, by the way. And when you will be more older, you will get more responsibility out of your work. And you have to make a balance with the family, with different situations. So it's not an easy one, but you can do it. But again, it needs patience, and because to go in university, so having a master program going to the university is not a good idea. So it's better if you have a PhD fund and you want to continue PhD and you are more oriented to research. So now going there. But if you want to stop at a master and go to university, I don't recommend this. I recommend this, go to the industry and give some courses. So the main job will be you're working in industry and you have the passion of teaching. Then you can give some courses, but will be your high commitment will be based on the industry work, which is your main income will come. And if you have the teaching patch, you can give one course or two courses in the university after you finish your master. However, if you want to be the main commitment being teaching, then I highly recommend you to go on PhD directly. Because if you stop after master and doing PhD after a long time, you will not able to do it, because the more older you will have more responsibility, and PhD need more commitment. So anyone who finish master, so in this case, he or she will be in the industry, and then the teaching will be at a passion, as having one course, two courses, and now will not affect your job in this case. Do you have any more questions, Josh, in this topic you want to discuss it before we leave today?
No, I think that's all.
Okay, guys, I want to thank you so much for today. So next lecture will be, we will have more practice using exam, and we will finish our course material in the next lecture. Like always, if you have any question, drop me an email. I will do my best within 24 hours to reply to your emails. Have a nice day all, and if you don't make the survey, I recommend that you do it. Thank you so much for you all. Take care. Enjoy the rest of the day. Bye-bye.
Thank you.
Thank you.
Unfortunately,
Thanks.
I cannot do 4:30. Too big of a time conflict, I think, even for a waiver.
Okay. Well,
Right.
still, I hope to see you again on other courses.
Yes, certainly.
Take
I
care.
quite enjoyed this course.
Yeah, and I also enjoy that you are here and the other here. I really enjoy it.
Thank you. All right, have a good day.
You too. See you next week.